Hi, this is Alexis Carter, and this is Lectures 2C1 on Clinical Workflow Analysis and Process Redesign, and Lecture 4F on Change Management. These two lectures were put together because they are a continuum of each other. This is the core content covered in this lecture. This is the core content just in larger font. Please note that the quality improvement sections of this lecture will be covered by another speaker. For section 2C1, we will be covering the design theory and components of workflow, workflow analysis, and process redesign. We will cover data collection methods and the tools that can be used to visually represent workflow. We will also cover process redesign and the steps to achieve that, as well as the relationship of process redesign and change management before we move into the section 4F change management aspect of this lecture. First, it's important to start with some definitions. Workflow is a process during which documents, information, or tasks are passed from one participant to another for an action according to a set of procedural rules. Workflow analysis is exactly what it sounds like. It's an analysis of the workflow or a study of how the workflow is performed. And process redesign, which is otherwise known as workflow re-engineering, is the process by which an existing workflow is redesigned into a different workflow. Now let's discuss workflow in some more detail. It's important to realize that workflow includes both mental and physical tasks, and that's certainly very true in informatics. It occurs at three levels. It can be individual or interpersonal. It can be between people or interpersonal within an organization, and it can also be between organizations. Workflow steps can occur sequentially in series, or they can be simultaneously in parallel. And another way to look at workflow is that it includes the movement of people and their actions, information, and objects through space and time. Moving on to workflow analysis. Workflow analysis is the study of an already existing workflow. Obviously, if a workflow has not yet been enacted, there's not really a good way to study it. When performing a workflow analysis, it is necessary to capture all aspects of workflow, remembering that workflow is not just information and objects, but it also includes people and their actions. The goal of workflow analysis is to reduce what is really a complex process into its individual components and to create a visual representation of the flow of people, information, and objects. The purpose of workflow analysis is to detect defects and waste, and workflow analysis can be anywhere from very high level to very detailed. Lastly, and probably the most critical aspect of workflow analysis, is that it is important to capture variations that can occur in a workflow in addition to the expected or normal workflow. In some circles, you'll hear the normal or expected workflow referred to as the happy path. Lean technologies are covered in more depth in another lecture. I do want to touch on them briefly here as they relate to workflow analysis. In the Toyota production system or lean system, the primary focus is on workflow, specifically as it regards the value stream. The goal is to eliminate waste, otherwise known as muda, so that every aspect of workflow can contribute to value. Gemba is another important term in lean, and this has certainly been true in my own practice, is that it is important to observe the workflow at the place where the work is performed. There are a lot of different theories and strategies out there on how to do a good workflow analysis, especially when it comes to information technology systems. For the purposes of this board exam, there are 4 categories of workflow analysis theories and strategies that you should be familiar with. There are computer science-based approaches to workflow analysis, computer-supported cooperative work theories, cognitive science theories, and organizational science theories. We're going to go into these in some more detail. Beginning with the computer science-based approaches to workflow analysis, Petri nets are a type of workflow analysis where there is electronic capture of the workflow anywhere a workflow touches an information system. Obviously, this requires system use data and a workflow management system to understand how the data being captured from the information system pertains to workflow. Because this type of workflow analysis is entirely limited to the interactions of a person with a computer system, there is very limited detection or no detection of interpersonal or non-system related elements of the workflow. Process mining is a type of Petranet that uses system log file data to construct events that have happened in sequence to depict what has happened in an information system. The next computer science-based approach to workflow analysis that you should be familiar with is contextual design. Contextual design provides a framework and a technique specifically for software designers so that they can understand primarily the human elements of a workflow. This is very useful for organizational workflow as well as individual workflow. So the way that a software designer would perform contextual design workflow analysis would be that they would start with contextual inquiry, where the software designer interviews the worker or workers in the field as they complete their tasks. The next step in the process is to create a model of the results of their contextual inquiry, and this is known as work modeling. And finally, they're going to consolidate the work models into a single statement of work practice. And the ultimate goal of contextual inquiry is to uncover 4 aspects of the work. The software designer wants to uncover the motive behind the tasks, the patterns that are used in carrying out the tasks, the structures that help enable that task to be completed, and any conceptual distinctions between the aspects of work which might have an impact on workflow. Moving on to the next category of workflow analysis, which is computer-supported cooperative work. So the goal of computer-supported cooperative work strategies and theories is to understand the activities of groups that are engaged in collaborative work activities for the purpose of software design. And up under computer-supported cooperative work are 2 main theories, activity theory and coordination theory. Activity theory states that humans engage in purposeful activities which are goal-directed and context-specific. So workflow analysis performed using an activity theory approach is useful for individual as well as for group workflows. By contrast, coordination theory states that task interdependencies among workers can result in harmonious goal achievement, because coordination theory is looking at how members of a group may be interdependent on each other or may coordinate with each other. This type of workflow analysis is useful for group workflow analysis, but is not applicable to individual workflow analysis, and that would be a great subject for a board question. Delving a little bit further into activity theory, you should be aware of an activity analysis and development framework, which is also known as the ACT-AD framework. This type of workflow analysis is done in 4 steps. The first step is to describe the activity network. The second is to assess the development of work activities over time as they relate to the current workflow, because this will help you determine goals for any new software or tool that you're bringing on board. The third step is to identify any existing goal conflicts in the existing workflow, and then to develop a future view of an activity network. And this last step is not exactly part of workflow analysis because it is, again, developing a future view rather than looking at the current workflow. Another type of workflow analysis that is performed according to the tenets of activity theory is the activity checklist. The activity checklist really helps to focus software developers on the work aspects relevant to software design. It helps direct their observations of work practices, and it has much more specific guidance than the ACT-AD framework. Within the activity checklist, there are 4 categories. The first is the means-ends category, which focuses on the hierarchical structure of activities within a workflow. The environment category, which focuses on the context of those activities. The learning, cognition, and articulation category, which focuses on the internal cognitive components related to those activities and the external actions related to those activities as well. And finally, the development category, which like the fourth step of the ACT-AD framework, helps the software designer to anticipate changes that will occur to the human actions that might occur when a specific new technology is brought on board. Going into a little more detail on coordination theory, which is another computer-supported cooperative work category of workflow analysis. Again, coordination theory states that task interdependencies among workers result in harmonious goal achievement. Further, it states that uncovering those task interdependencies can help identify new ways to manage those interdependencies. So, coordination theory really focuses on prerequisite tasks, tasks which require shared resources, and tasks that require synchronization between different people. So, coordination theory examines 4 processes underlying coordination and their components. Again, because we're trying to find those hidden task interdependencies. These 4 processes are coordination, group decision making, communication, and perception of common objects. An important term to remember that is associated with coordination theory is the tracer method. So a tracer method is where you tag an object and then map where the object flows in a workflow, particularly when you're looking at who all has handled the object as part of that workflow. The next category of workflow analysis theories and strategies is cognitive science. Cognitive science has become more increasingly discussed in our field in clinical informatics. Cognitive science is a very multidisciplinary field that concentrates on human thought processes and understanding those human thought processes. It includes how humans attain knowledge, how we remember things, and how we problem solve. There's several references for this as well as for everything else in this talk in the references that have been provided, as well as the ones on this slide. There are a couple of approaches that you should be aware of within cognitive science. The first is cognitive task analysis. Cognitive task analysis is a group of methods to examine individual human tasks. And 2 examples of cognitive task analysis are cognitive walkthrough and a think aloud protocol. A cognitive walkthrough is a type of cognitive task analysis that is performed by a systems analyst, and it is a form of workflow inspection. The system analyst will perform the cognitive walkthrough in the presence of system users, and the analyst may ask the system users to verify their perception of what the system users are doing at the time they're performing the cognitive walkthrough. The goal is for the system analyst to try and simulate a user's cognitive processes as they engage in tasks with an information system. By contrast, a think aloud protocol, which is another form of cognitive task analysis, is performed by a system user, not a system analyst. And the system user performs a think aloud protocol as a form of workflow testing, as opposed to workflow inspection. The system user verbalizes their thought processes as tasks are carried out, and an analyst can record that verbalization into a visual representation of the system user's mental model. So again, while a system user and an analyst may both be involved in a think aloud protocol, the actual protocol is a form of workflow testing performed by the system user, whereas an analyst may just be recording that verbalization into a visual representation. Another cognitive science approach to workflow analysis is distributed cognition. Distributed cognition studies the collaborative nature of human cognition. As we all know, people and objects are constantly interacting within a framework of social and cultural practices. One specific type of distributed cognition is called the User Functional Representational and Task Analysis, which has an acronym that I am not going to dare try to say on this recording. However, this particular type of distributed cognition, user functional representational and task analysis, can be used for workflow analysis at all levels. It occurs in 4 phases. There's a distributed user analysis, functional analysis, a task analysis, and a representational analysis. Now please note that in the name of this particular task analysis, representational and task are reversed from how they are actually performed. A task is the 3rd phase and representational is the 4th phase. Moving on to the last category of workflow analysis theories and strategies. The last category is organizational science. Organizational science really aims to clarify internal organizational structures that can influence change and direct process redesign. So there are two components of organizational routines. There's an ostensive aspect, which refers to the general pattern of a routine, and the performative aspect, which are the specific actions performed by individual people within specific contexts. Also within organizational science is the concept of artifacts, which basically means the physical manifestations of the routine. Okay, so let's consider the following question. Petronets are distinct from other types of workflow analysis because they A. require the use of process mining, B. require the use of software to capture data, C. are better than other approaches at detecting interpersonal and non-system related elements of workflow, or D. are a computer science-based approach. So the correct answer is B. Petronets are distinct from other types of workflow because they require the use of software to capture data. They're the only type of workflow analysis that we described thus far that is absolutely dependent on software to capture data. All of the other workflow approaches could be performed using paper. The reason why A is not correct is because process mining is a type of Petronet, but using a Petronet does not require the use of process mining. The reason why letter C is not correct is because, if you remember, Petronets only detect elements of the workflow that touch the computer system. It does not detect interpersonal or non-system related elements of the workflow. And the reason why D is not correct is because there are multiple computer science-based approaches, of which Petronets are one of them, so Petronets are not unique because they are a computer science-based approach. Let's consider another question. Which workflow analysis approach is specifically designed for software designers to understand the individual human's actions in the workflow for which they are trying to design software? A. Petronets, B. Computer-supported cooperative work, C. Lean technology, or D. Contextual design. So the correct answer is D. Contextual design. The reason why A is not correct is because Petronets are basically systems where you are looking at computer log files or system data to try to recreate the computer-based components of a workflow. Answer B is not correct because computer-supported cooperative work is a category of workflow analysis theories and strategies that includes activity theory and coordination theory. This category of theories and strategies is not specific to software designers. Lean technology does have workflow analysis approaches associated with it, but these are certainly not limited or intended to be limited to software designers. Now we're going to move on to specific data collection methods that can be used for workflow analysis. Any data collection method used for workflow analysis needs to represent how people interact with existing technology and their roles as they interact with this technology. It's important to capture temporal dependencies. You need to make sure, particularly with information systems, that you capture existing system triggers that will generate certain tasks to be performed by the humans who are doing the workflow. And you also need to catch any of those if-then conditional workflows. And lastly, but certainly not least, it is very important to capture those creative workarounds that people may have put into a workflow. These creative workarounds, while they may seem to be the bane of the existence of many of us, those creative workarounds are often incentivized or developed because there is a significant gap in functionality. Uncovering a creative workaround may mean that you have then uncovered an unknown gap in functionality. Data collection methods can be either quantitative or qualitative. A quantitative collection method is typically collected via an operational system, but it can also be collected by a detached human observer. Unfortunately, these collection methods aren't much fun for the humans because they often involve counting events. Qualitative data collection methods are much more common, and this is where the person doing the workflow analysis tries to capture the details of everyday work practices. Ethnographic observation is an example of a qualitative data collection method, and ethnographic observation can include observing participants, trying to attend to meaning, the goals, and the context of things happening in workflow, as well as to how people communicate with each other during workflow. Now, as you can see from this slide, there are many methods to data collection for workflow analysis. Some of these methods are quantitative, some are qualitative, and some are both. We aren't going to go through all of these, but we will cover a few of these in the next slides, which I think are more likely for you to be asked about during an exam. One data collection method that you should be aware of is grounded theory. So grounded theory is an ethnographic method which uses inductive rather than deductive analysis. In deductive analysis, which is what most of us use when we are doing research, we propose a hypothesis and then we do our research in order to determine whether or not our hypothesis is correct. In inductive analysis, there is no hypothesis that is proposed at the beginning of the research. Instead, the analyst performing grounded theory analysis collects the data in iterative batches and then analyzes the data as it's coming in. Each event captured in the workflow is broken down into smaller components, and those smaller components are coded. Those codes are then combined and related into categories or concepts, and then the hypothesis or theory of how a workflow is being performed is derived. This type of data collection method is very useful when you're trying to uncover hidden triggers to a workflow or cultural taboos that may prevent people from doing certain tasks during a workflow. Usability is another method of collecting data in a workflow analysis. Usability incorporates 5 attributes that must be evaluated in the information system. Learnability, or how easy is it to learn. Efficiency, meaning does the information system make an experienced user more efficient than they would have been without it. Memorability, how easy is it for users to remember what they're supposed to do in the information system in order to complete a certain task. For errors, does the information system help minimize error? And if there is an error, does the information system help the system user easily detect it? And lastly, satisfaction. Are users happy about using the information system? Now let's discuss workflow analysis tools. The most basic workflow analysis tool is a simple flowchart. It's also known as a process map. Simple flowcharts are really good at representing actions and decisions through time. They're very well suited to high-level workflow analyses, but they're less good at more detailed workflow analysis, which requires that we capture who's doing what or which specific roles of individuals and which actions and decisions are being made by those individuals. This is an example of a simple flowchart. The beginning and ending of a workflow in a simple flowchart are often represented by circles. Sometimes you'll see the ending represented by a stop sign or a terminator flag. When decisions need to be made in the workflow, those are frequently represented by diamond shapes, and then processes in the workflow are represented by boxes. In this example, the workflow begins with the patient arriving, and then a decision point comes in where you have to determine whether or not the patient is in the system. If the patient is not in the system, then you move to the process just below that decision point, as referenced by the arrow that says no, and the patient has to be sent to complete additional paperwork. If the patient is in the system, then you follow the arrow that says yes, and that takes you to another decision point. The workflow continues until you get to the bottom where the patient leaves the event. Now, you should note that for each step in this process, it isn't always clear which individual is performing that task or making that decision. A swim lane flowchart takes a simple flowchart to the next level in that it uses swim lanes to represent the various functions of each person's role in a workflow, in addition to the processes and decision points that occur during a workflow. It is a really great tool for picking up redundant workflows and inefficiencies. In this slide, we have a simple swim lane flowchart. You'll notice that there are 2 swim lanes. One swim lane is for the medical technologist or resident, and the other swim lane is for a pathologist. The workflow starts with the medical technologist or resident in that a preliminary laboratory result goes to in review status in the review queue, but you'll notice that the next step in the workflow process is performed by the pathologist. You'll also note in this workflow that there is a loop that starts from launching the review queue down to requiring corrections, and then if corrections are required, one of two different loops back to the original launching of the review queue can take place. Any type of approval process is obviously going to result in a loop because the whole purpose of a review is to ensure that something is complete and accurate before it moves to the next step. If it's not complete and accurate, then it will require modifications and then we'll have to go back through approval. However, you certainly want to eliminate any unnecessary loops as they are very inefficient. So this is another example of a swim lane flowchart where it is more complex. We have 6 different types of individuals who are involved in this workflow, and you'll also note that there are no less than 7 loops in this particular workflow. I'm happy to state that we no longer use this workflow at my institution because we have dramatically streamlined it, but this workflow was such a good example of how a swim lane flowchart can help you detect inefficiencies and complexities in a workflow that I felt it was very important to include this as an example. A spaghetti diagram is a physical map of the movements of people in a workflow. I think most of us would agree that if a workflow requires a lot of walking, particularly if that walking is back and forth between different places because one thing or another needs to be retrieved, that walking is waste to the process. It's not uncommon for a poorly configured information system to create a lot of waste. In the spaghetti diagram example on this page, you can see that there's a waiting room, there are phlebotomy collection areas, and a laboratory, and each one of the individuals in this specific workflow are represented by a different color. You can see in this workflow that both individuals are walking back and forth between various areas multiple times to achieve the completion of this one workflow. As with any workflow analysis tool, comparing this tool collected before workflow redesign and then again after workflow redesign can really help demonstrate improvements in process. In lean technology, a common workflow tool to use is a value stream analysis. In a value stream analysis, you want to document all steps required in order to complete a service from beginning to end. A value stream analysis includes both steps with and without value, and you specifically want to document the time that it takes between steps and use that to create a value stream map. This is an example of a value stream map which is looking at phlebotomists collecting patients on the floor. The value stream is represented by the boxes and arrows about 2/3 of the way down the page where you see a box with a person and then an action and then a box with a person followed by an action. Variations in the workflow are represented by the dotted line and another person box and an action coming back to another step in the process. Areas that represent interruptions and possible waste are represented in red, and the time that it takes to complete each step in the value stream is shown at the bottom. So value stream maps can really help you indicate where the value-added processes are, and then there are ways to annotate when you have one of the 7 different types of waste that can be seen in a workflow. Those 7 types of waste are covered elsewhere in this course. So let's try another question. A swim lane flowchart differs from a simple flowchart in that it A. focuses on the value stream, B. is a physical map of movements of people in the workflow, C. visually represents the actions taken by various roles, or D. maps out the steps in a process. The correct answer is C. A swim lane flowchart differs from a simple flowchart in that it visually represents the actions taken by various roles in the workflow. The reason why A is not correct is that a value stream map focuses on a value stream. A swim lane flowchart and a simple flowchart simply focus on the workflow and don't necessarily have any indicators in them as to which processes contribute value. The reason why answer B is not correct is because answer B represents a spaghetti diagram. And the reason why answer D is not correct is because both a swim lane flowchart and a simple flowchart map out the steps in a process. Moving on now to process redesign. Process redesign is also known as workflow re-engineering. As the name implies, this is where you are looking at an existing process or group of processes and then determining what redesign of those processes is necessary and then putting that redesign into action. Process redesign is a fundamental component of continuous quality improvement, total quality management, and just general process improvement. There are many different models of process redesign. Lean and Six Sigma, I think, are the ones that most of us are familiar with, although ISO also has process redesign that some of you may be using. Regardless of which model of process redesign you are using, there are steps which are common to all of the methods. The first is that you would perform a workflow analysis. The second is that you would determine an ideal workflow, followed by a gap analysis. You would mitigate obstacles to the ideal state, finalize your planned future state, do your testing, implement your change, measure your outcomes, and then determine or describe your next future change. And then you would repeat the cycle all over again. We're going to go through these steps in a little more detail. We've already gone through workflow analysis in some detail. For the next step, determining your ideal future state workflow, obviously you want to base your future ideal workflow on evidence as much as possible and best practice. Obviously, ideal may not always be practical or feasible financially or otherwise, but if you can achieve at least some components of your ideal state, you'll be that much closer the next time you do process redesign. A gap analysis is a determination of the gaps that exist between your current state and your ideal future state, and it should also include an evaluation of how you might be able to close the gaps. Are there obstacles or barriers to that ideal future state that will need to be addressed prior to putting your process redesign into place? A gap analysis should also include action plans to mitigate obstacles where that's possible, but as previously stated, you may not be able to resolve all of them. There are a number of published tools which are helpful in doing a gap analysis that are published on the Agency for Healthcare Research and Quality website, among others. There's a web link here, and there are references listed for this lecture as well. So again, after your gap analysis is completed, you want to mitigate those obstacles to future state where you can, develop the final details of the change to be made, which some would call your final future state plan, do your testing to ensure that your final future state plan will be possible, implement the change, and then measure your outcomes. I would just like to note that in measuring outcomes, it's very important to make sure that you measure baseline data. Otherwise, sometimes it can be very hard to measure the change that you've made. So after you have implemented your change and measured your outcomes, the next step in process redesign is to plan the next change for the next cycle or iteration of your continuous quality improvement. One mechanism that you should know for the board exam of planning such a next change is called a logic model. A logic model is a picture of how the next change is supposed to work, and the logic model should occur prior to workflow analysis for that next iteration. A logic model is also known as a theory of change or a roadmap, and it has several components: a purpose, the context of the next change, the inputs, the activities and the outputs, and then the anticipated short, medium, and long-term effects of the next change. In this slide, I've included a diagram which gives you an overall framework for how change management and process redesign occur over their iterative cycles. In the top line of this diagram, you'll see the steps that we just described for process redesign. In the next line, which is in purple, you'll see the analogous phases of Plan, Do, Check, Act. Some of you may know this as Plan, Do, Study, Act, or PDSA, where planning represents really the first 5 phases in process redesign. The do represents your testing and implementing of your change. Checking means measuring your outcomes, and then acting and adjusting means determining your next future change that is needed. You'll also notice that I've incorporated project management. Project management is where you have a project, the start of which is starting your process redesign, and the end of which is when you have implemented the change and have done your heightened vigilance afterward. We will go into project management in more detail in section 4D. Maintenance is where you're measuring your outcomes and then determining your next future change, because during that period of time, you are maintaining the change that you just made until the next change is made. At the bottom, you'll see that change management and process redesign really happen along this process, and it's iterative. You can't have process redesign without good change management strategies, and change management is fairly useless without process redesign. There are a couple of good articles on the reasons why process redesign, and specifically process redesign using lean technology, can fail. The first is a failure to undergo all of the steps of process redesign. There are a lot of steps to process redesign, and done properly, this can be very time consuming. Failure to collect your baseline data or to do your current workflow analysis is a common reason for this failure. However, other reasons can include a lack of sustained leadership support for your continuous quality improvement or process redesign initiatives, misaligned incentives between groups who are engaging in process redesign, a lack of communication, inadequate people, time, or money, poor usability of the system, inadequate training, an underestimation of the complexity of the process that you are trying to address. This is one of the reasons why Lean really focuses on these very small iterative changes. Lack of robust measurement and data feedback systems, as we previously discussed, and then also cultural resistance to change or hostility toward information systems. I think many of us who take this particular board exam have experienced that in the past. But one of the big reasons that I want to highlight, mainly because it's a great segue into Section 4F, is inadequate or no use of good change management strategies. So now we're moving on to change management. This is Section 4F of the board review course. Here are the pieces of the core content that we will be covering. The key topics in change management are that change is really more rapid now than ever before. I think all of us are aware of that. And this really can increase resistance to further change if change is not managed appropriately. Any successful process redesign requires good change management skills, and affecting change really requires that you know your audience. You need to have a framework for how you're going to enact change, and then you need to tailor your strategy to the affected culture and user groups involved in that change. So what is change management? Change management is an approach to transitioning individuals, teams, and organizations to a desired future state. And again, successful process redesign requires the use of change management. And as clinical informaticists, we are enacting change all the time. This is part of the reason why change management is a requirement on your board examination. I think all of us would agree that change is really very rapid now, much more so than ever before. In healthcare, it seems like every week they come up with new regulations for us to follow. Our systems are changing on a constant basis, whether it's because we have an operating system patch or a virus or ransomware that we're trying to protect against, not to mention all the cleanup and process improvements that we're trying to enact in our information systems. Now, some cultures are much more willing to embrace information technology and also information technology changes than others, but that isn't always obvious on the surface. So it really is important to assess environmental readiness in your organization for planned changes, especially for larger or more significant changes. This type of assessment generally includes assessing the level of organizational stress, the amount of human, financial, or time resources that you have available, and the degree to which your organizational leadership is going to embrace and support change. The good news is that change is possible in any organization, but more resistant organizations may require more upfront work, with change management strategies being more heavily employed. If the affected end users are not engaged in the change, it is likely that the change may fail. And this is why most change management strategies and theories focus on the people involved in change. One of the most helpful things that you can do in assessing the existing culture or attitudes towards change is to look at your recent organizational change history. Have there been recent changes in leadership? have there been recent changes where the affected end users were significantly unhappy? What decisions did people make when there were problems that occurred after a change was implemented? Also looking at existing resource constraints across the organization and any conflicting organizational priorities or conflicting priorities between groups within the organization can be extremely helpful in helping you to mitigate problems and ease people's fears about change. In the core content under change management, there are some specific change theories which are specified, so we are going to go through those. The first change management theory or strategy is what's called precede proceed. There's a great explanation of this change management strategy in the community toolbox provided by the University of Kansas Community Health Department. Although precede and proceed are certainly names, in this case they actually refer to acronyms. So precede stands for predisposing, reinforcing, and enabling constructs in educational environmental diagnosis and evaluation. Proceed is for policy, regulatory, and organizational constructs in educational and environmental development. Obviously, I don't think I would spend a lot of time remembering what all the acronyms stand for, as long as you remember that precede, proceed are acronyms. The other thing to remember about precede, proceed is that precede occurs first and proceed occurs afterward. Precede is known as the diagnostic phase for change management. This is where you're assessing your organization's ability to be able to engage in change. So it occurs in 5 subphases. There's a social assessment, an epidemiological assessment, behavioral and environmental assessment, an educational and ecological assessment, and then an administrative and policy assessment. Proceed is the second major phase in this change management strategy, and it is an evaluation phase. So precede is diagnostic, proceed is evaluation. And in proceed, this occurs in 4 subphases. The first is an implementation of the intervention. The second is process evaluation. The third is impact evaluation. And the fourth is your outcome evaluation. Now notice that these steps all follow very similarly into your workflow re-engineering process. This slide shows a diagram of precede proceed, so you'll notice that in the top half of the diagram, phase 1 starts on the very right hand side where the green arrow is, starting with social diagnosis, followed into phase 2 by epidemiological diagnosis and so on. And then after you get to phase 5 on the left hand side of the screen, you would wrap around down to the bottom on the left hand side and then start the proceed half of the cycle, which starts with phase 6 in implementation. The other thing to note about this diagram is that it pairs up the different phases between the precede half and the proceed half of the change management model, and indicates which factors and aspects of change management are getting the focus during those phases. For example, predisposing factors for change, reinforcing factors for change, and enabling factors for change are part of phase 4 in the precede half, which is educational and organizational assessment or diagnosis, and also in phase 7, which is your immediate post-implementation evaluation period. Also, I've seen several iterations of this diagram, the most recent of which is not publicly available, but rightly incorporates genetics into the phase 3 and phase 8 aspects of this process. Every day it seems that the impact of our inherited genetics as well as acquired genetic changes are coming into focus when it comes to the decisions that we have to make and the changes that we have to make in order to improve our own health and quality of life. As was stated in the previous slide, precede-proceed change management strategies were originally developed for use in community and public health improvement initiatives. However, this change management strategy can be used in a number of different environments and should not be limited to the public health setting. The advantages of precede-proceed are that the planning process is very prescriptive and you're unlikely to leave issues or people out of that process. It also uses a ranking system to help facilitate those determinants for change at the individual provider and system levels. The next change management theory, which is specifically listed in your core content, is social influence. Before we get too much into social influence, it's important for us to go through some definitions. Social influence itself is a change in behavior that one person causes in another. Now, that change can be either intentional or unintentional, and it usually happens as a result of the way that the changed person perceives themselves in relationship to the influencer. The influencer can be a single person, it can be a group of people, or society in general. Conformity is when a person changes how they behave in order to be more like or to conform to others. There are a few subtle differences between the definition of conformity and compliance. In conformity, a person is changing how they behave without having been asked to do that by others. In other words, the change is unsolicited. However, with compliance and obedience, a person is doing something that they are asked to do by another. The difference between compliance and obedience is that in compliance, a person performs an action that they're asked to do by another, but believes that he or she has a choice in accepting and performing that task. By contrast, in obedience, rather than performing a task, a person believes that they are obeying an order from someone that they believe that they cannot refuse. Now that the definitions are out of the way, we can progress to the actual change management theory, which is the social influence model of technology adoption. This model states that conformance to subjective norms play a very central role in technology adoption. I think many of us have seen this in play, where we see that if one person adopts a certain piece of technology, many others will start to follow in order to identify with that person or group of people who are your early influencers. This model states that social influence, then, is at the confluence of 4 social computing phenomena. We'll describe these more in the next slide. These are the 4 social computing phenomena, at the confluence of which is the social influence model of technology adoption. Therefore, social influence is at the confluence of action, or the actions performed through the use of a piece of software; consensus, which is agreement from all the end users that it's right to carry out those actions; cooperation, which means that the users are using the software and participating with it in a way that's in the best interests of the group; and authority, meaning that the authority or acceptance of the group supersedes any traditional authority on the use of the software. In this slide, I've put a couple of examples as to how the social influence model was used to promulgate the use of certain products. In the 1980s and 90s, Apple had a very low percentage of the market. IBM PCs and eventually Microsoft had the vast majority of the market share. However, there was a huge ad campaign which showed users of Apple devices as being hip and cool and mobile, and that combined with some of their user interface advances really helped individuals adopt and purchase Apple technology over Microsoft. Twitter may even be a more dramatic example in the sense that in 2008, only 5% of the United States public were actually aware of what Twitter was, and there were far fewer people actually using it. However, as you can see in the table that I've put over to the right, even prior to the last presidential election, public awareness of Twitter had dramatically risen in the space of about 3 years, from 5% to 92% in 2011. In 2014, the usage of Twitter had increased to approximately 27.8% of the U.S. population, and in 2017, practically everyone is aware of this platform, even if they don't understand it or use it, simply because of its impact in politics and its pervasiveness in the news. In order to utilize the social influence model of technology adoption, you need to have leadership, and your leaders need to provide a common goal for your end users, which requires the use of technology adoption to achieve that goal. As an example, if your healthcare system is applying for a Stage 7 certification under the HIMSS Analytics EMR adoption model, which is covered elsewhere in this course, that would be a goal that requires technology and would be a benefit to the healthcare system as a whole. This model requires that you foster your users' feelings of acceptance by the medical community because they adopted the technology. And because of that, it's really best used when the effects of the technology are easily visible and can be tried out by the end users. So this model might work well for the vast majority of your end users if you are doing an EHR upgrade, which has a lot of new features which will help streamline workflow. However, if you're upgrading your laboratory information system, this probably isn't the best model to use for your physicians and staff who only interact with the EHR. Having said that, it may work very well for the laboratory staff. So you can run into certain projects or situations where selective use of certain change management strategies may be more effective than trying the same change management approach on everyone. The last change management theory, which is listed in your core content, is complex adaptive systems. This is also known as complexity theory or systems theory. And this theory effectively states that change is very dynamic, it's nonlinear, and it can be very unpredictable in its effects. In complex adaptive systems, individuals are to organizations what organisms are to ecosystems. The individuals in an organization are stated to coexist and depend on each other for system or organization survival. And in these systems, individuals are assumed to be independent, intelligent agents, that the goals and behaviors of a single person often conflict with that of another, and that organizations are actually able to adapt and learn on their own or to self-organize, and that there is no single point of control in change. And I think anyone who works in clinical informatics is very aware of how much truth there is to the basis of this theory when it comes to effecting change in a healthcare system. People who study complex adaptive systems analyze these complex relationships between the different components of a moving system. There are some who work in this field who try to apply certain mathematical models to these systems in order to predict outcomes based on a huge number of input factors, and others really study behavioral aspects of change in these complex systems in order to determine what behaviors and cultural environments foster appropriate change rather than inhibit it. This theory states that, in general, ease of access to information will improve the performance of a complex adaptive system, and that incentives are essential to productivity and wellness. However, as we discuss in section 4a, those incentives are far more likely to be successful when they are intrinsic motivators rather than extrinsic. Studies in complex adaptive systems really focus on creating the conditions that will foster adoption of change iteratively and in a positive way. Needless to say, the strategies that you would adopt in a complex adaptive system model would be most helpful when you're in the planning phase of a change and also at very early implementation. These systems models prepare for unpredictable behavior and help foster adaptations to that behavior. While not specifically listed in your core content, there are a few other change theories that are very important for you to know. The first is the diffusion of innovation theory. Innovation in this case is the change that you're making, and this theory states that there are 5 characteristics of innovations which make them the most influential for the affected end users. These characteristics are the perceived benefit of the change by the end users. Can the users observe the actual change? Is the change compatible with the current organizational culture and personal beliefs of the end user? Is the change relatively simple, because that will help foster its adoption? And can the user try it out prior to having to use it in production? This graph should be familiar to many of you. This is the graph which shows the adoption of a new change over time, and this graph correlates the users who adopt change with the number of overall people who have adopted the new change or technology. On the far left, the first people to adopt change are known as the innovators, followed by the early adopters, the early majority, the late majority, and then finally the laggards. The diffusion of innovation theory states that the tipping point for being able to get everyone in your environment to adopt a new technology is really once you get to about 15 to 20% of your users. So if you look at the percentages of people who fall into the various categories, your innovators and early adopters have to have fully accepted the change, and then you have to start getting into your users who would fall into your early majority in order for you to be fairly certain that the change will be adopted by the majority of people. So the good news about this graph is that you only have to get about 15 to 20% of your users to fully adopt the technology before you can be reasonably certain that the rest of your users will follow. However, the bad news is you can't just stick with your innovators and early adopters. You do have to make sure that you get more broad adoption outside of your usual technophiles. This graph might provide excellent fodder for board questions, so I would definitely be familiar with it. Now, as with any change, sometimes even when that change is good, there can be a bit of a grief process in letting go of the old way that you used to do things. And so it's important to be aware of the Kubler-Ross grief cycle. I often remember this cycle as DABDA, and that is the first letter of each one of the phases, which goes in order: denial, anger, bargaining, depression, and acceptance. For those of you who are psychiatrists or who remember psychiatry in medical school, this should be familiar. The next change theory you should be aware of is Bridges' transition theory. This theory states that the psychological transitions of people are more difficult than the technology change itself. So you should be thinking about the 80-20 rule, that change is 80% people and 20% technology. And this falls right into line with what Dr. Warner used to say about informatics, which is that informatics is 80% sociology. In Bridges' transition theory, there are three phases of change. The first is basically loss, ending, losing, and letting go of the former way that you used to do things. The second phase is a neutral zone where there is some confusion and chaos, an attempt to realign to the new way of doing things. And then the third phase is more positive. It's a new beginning where there's energy and purpose and embracing of the change. Lewin's change theory is very similar in that there are three phases. The phases are similar in the activities that occur in them, but the naming of those phases is different. The first phase is known as unfreeze, where you're preparing for change, overcoming inertia and resistance. The second phase is the actual change, and the third phase is refreeze, where your post-change circumstances will crystallize and you will have increasing comfort with the new way of doing things. Moving on now from change management theories to change management strategies. In this paper from Cotter and Schlesinger in 2008, there's a description of a number of change management strategies which will be helpful for the board examination. They state that one of the most important things to do in change management is to diagnose resistance. The four most common reasons for resistance are parochial self-interest, misunderstanding and lack of trust between individuals, different assessments of the perceived benefit. Again, perceived benefit seems to be coming up over and over again between different theories and strategies. And another very common reason for resistance in some organizations is low tolerance for change. So the strategies that this paper offers in dealing with resistance are education and communication with your end users, getting your end users involved and actively participating in the project, facilitating and supporting your end users through the change, negotiating and getting agreement where there are conflicts during the change process, and then some more active mechanisms to deal with resistance include manipulation, and co-optation is a term that you should be familiar with for the board exam. This is a form of manipulation in which you give an end user a key role in the change design or the implementation in order to help get their buy-in. And then, of course, you have explicit and implicit coercion. Like many other things that you will learn in Section 4 of the core content, the change management strategy that you choose to use should depend on the situation that you're in. Things to consider are whether or not the implementation you are undertaking has to occur very quickly or can it occur over a longer period of time. You should also consider the organizational culture before a strategy because, again, the most important thing that you can do in change management is to first diagnose any resistance that might be in place. It's important to understand the power and the political capital of initiators versus more resistant individuals in your organization, as well as the amount of energy that it will take to implement the change and the consequences of not making the change, as this may help you win over those individuals who may be more resistant. There are also change management strategies listed on the healthit.gov website, specifically for EHR implementations. In this primer on change management, they list three separate phases for successful EHR implementation. The first phase is creating a climate for change where you establish a sense of urgency, you build a coalition, and create a vision for the future state. In phase 2, you want to engage and enable the organization. So you communicate the future state, you empower others to perform actions that will help drive towards future state, and then plan for and create short-term wins to enable users to have a feeling of success and progress. In phase 3, you would implement and sustain the changes, offer training, retraining, and technical assistance, and also celebrate your successes. Finally, we're going to go through a few strategies for adoption and use that are specifically for information systems. You should be aware of this paper from 2016 by Cruz et al., which did a systematic review of studies that cited barriers and facilitators to adoption of an electronic health record. In many of the change strategies and theories that we've discussed previously, you'll note that the perceived utility has been cited as an important factor, and I think the fact that it has been perceived as both a barrier as well as a facilitator to adoption supports this. The barriers to adoption are what you might expect. An EHR is extremely expensive, so cost is a significant barrier. It's also very time-consuming to implement an EHR, and data migration is also an incredibly important barrier to adoption as well. Facilitators to adoption include efficiency. If you are a large organization, you'll achieve economies of scale with an electronic health record, the improved quality of care and access to patient care by being able to widely distribute information to those who need it, especially across multi-facility healthcare systems. The Qualis Health experience in primary care settings for EHR adoption cited 6 barriers to effective implementation of an EHR, and these surrounded leadership, workflow, providers, training, data interfaces, as well as graphical user interfaces. For each one of these barriers, they listed mitigation strategies, and most of these are common sense, but one that I really want to point out is the mitigation strategy under workflow. Standardizing your workflows before you implement a new system is critically important. And it's also important, in as much as possible, to have standardized workflow in your graphical user interfaces and beyond, because then there is a consistent, expected process to follow. Standardization and consistency makes it much easier for users to adopt new technology. The other mitigation strategies are very similar to those we have previously discussed in both the change management theories and the change management strategies. You should also be aware that under meaningful use, the federal government established a national program of regional extension centers to help with small practice EHR implementations. And in this paper by Torta et al., they describe their experience with barriers and facilitators to adoption using these regional extension centers. Okay, so let's end with a couple of questions. The terms early adopters and laggards are most commonly associated with which change management theory? A. Diffusion of Innovations. B. Transition theory. C. Social influence. D. Kubler-Ross grief cycle. So the correct answer is A, Diffusion of Innovations. And again, this references the graph that I showed you earlier in this presentation. The reason why B is not correct is because B is transition theory, and this theory, otherwise known as Bridges transition theory, is the theory that states that psychological transitions of people are more difficult than the technology change itself. The 3 phases of change in transition theory are ending, losing, and letting go, the neutral zone, and new beginning. The reason why the social influence model of technology adoption is not correct is because while there are a lot of similarities in the way in which change is adopted between the 2 theories, the social influence model does not describe specifically early adopters and laggards. The Kubler-Ross grief cycle simply mentions the phases of grief that a person may go through after a loss. This is where your DABDA acronym comes in handy for denial, anger, bargaining, depression, and acceptance, in that order. Again, the Kubler-Ross cycle does not describe early adopters or laggards. So let's do another question. Which of the following are among Cotter and Schlesinger's change management strategies to deal with resistance? A. Innovation, communication channels, time, and social system. B. Manipulation and co-optation. C. Unfreeze, change, and refreeze. Or D. Compliance, identification, internalization, and conformity. The correct answer is B, manipulation and co-optation. And remember that co-optation is a term in which you give an end user responsibility in ensuring the success of the change to help get their buy-in. Answer A is not correct because it actually has no relation to anything. Answer C is not correct because this refers to Lewin's change theory. Answer D uses a couple of terms that we've discussed in this lecture but actually doesn't relate to Cotter and Schlesinger's change management strategies. So that's a wrap for this lecture. Thank you very much for your patience. I hope that despite the rather brute memorization that's required to remember all of these management strategies and theories, that you have found this informative and will be able to use it in your practice as well as to help you with the board exam.